Alright, so let's recap a little bit. So we say that integrals with unbounded limits of integration so integrals with unbounded limits of integration, these are called improper integrals. Okay, and the way we do them, and the way we actually integrate them, it's quite simple. It's the same thing that we did before. Let me give the definition here. So definition, if I were to integrate from, say, a to infinity of f of x dx, here's what you do. You're going to take the limit as b goes to infinity, where b is some finite number, so you're allowing that finite number to get large, just like in the previous example, and you're going to go from a to b of f of x dx, if the limit exists. So what happens is that if you ever see infinity, what you're going to do is you're going to turn it into something like b. Just say, okay, let's see what happens at b, and then take that limit to infinity. Now, if that limit exists, then we have another word. We say the improper integral is convergent. Else, it is divergent. Okay, so let's do an example. So let's consider the integral from, say, e to infinity for 1 over x dx. Now, it's always good to look at and know what the picture looks like. Okay, so what the picture is I'm going to integrate this curve here. This is the curve. And this is the curve y is equal to 1 over x. And I'm going to integrate this from, say, e. Remember, that's roughly 2.71. And I'm going to find the area under the curve, if it's possible, if the limit exists, to infinity. Okay. Now, here's what you do. First thing I'm going to do is say, okay, well, this is the problem. This is what I'm having the issues with. I'm going to infinity. So I'm going to write it as a finite definite integral. And I'm going to write this as the limit as b goes to infinity from, say, e to b. So I'm only looking at a finite interval, 1 over x dx. So again, what I did was I took the infinity, turned it into a small number like b, whatever that is, any number from e on. So it could be 3, 5, 8, 10. And I'm going to allow that number to get arbitrarily large. Okay. So this is going to turn into the limit as b goes to infinity. And the antiderivative of 1 over x is the natural log of x, absolute value of x, don't forget. But everything is positive, so we're okay. And that's going to go from e to b. Okay. Now this is going to turn into the limit as b goes to infinity for the natural log of b minus the natural log of e. And like I said, they're both positive, so we don't need to write down the absolute values. Now we know what happens here. This just turns into 1. So this is really just left with this integral here. The limit as b goes to infinity for the natural log of b, and then I'm going to subtract 1. Okay, so how do we compute this limit? Now this is a very geometric reasoning, but remember what the natural log looks like. So you should definitely know what the basic functions look like. Exponentials, 1 over x, that kind of thing. And you'll see that the natural log of x looks like this. Right? And this goes to the point here at 1, 0. Alright, and of course at e, which is bigger than 1, remember e is about 2.7 and keeps going forever, is roughly going to be 1. But we see that the natural log of x continues to rise. It's a monotonically increasing function. It goes up to infinity. So this actual integral, this actual limit, is equal to plus infinity. Now since that is not a finite number, we say the integral is divergent. So if you ever get an answer like infinity, it's divergent. If you get something that doesn't even have a limit, it's divergent. So the only time it's actually convergent is if it actually equals a number. So in the previous example that we just did on the last page, we actually see that this is convergent because this is equal to, as we just did this limit, is equal to 1. So we say that this limit is convergent. This guy is convergent because we get a finite answer. So we're looking for area under the curve that's going to be finite. Now this is kind of an interesting idea because notice here 1 over x, that's infinite. 1 over x is infinite, but yet 1 over x squared is finite. So that actually is a finite area.